Hey there, this is Mr. Alexander, and today I want to talk to you, Pre-AP Algebra 2 students, about how to write transformations graphically of absolute value functions. So the notes we are given on this unit were, the first thing it asks you to do is write the domain, range, y-intercept, and x-intercept for the absolute value parent function. Well, you might remember doing this 5 or 6 weeks ago. Maybe even more. Remember this little thing we had you put in your journals? This is the absolute value parent function. Y equals the absolute value of x. And so the graph, it looks like a V. The domain is just negative infinity to positive infinity. That's how far left it goes, how far right it goes. It goes out to the left forever, it goes left forever and right forever. The range is how low to how high. It goes from 0 to infinity. The y-intercept's where it crosses the y-axis, which is right here at 0, 0. Same for the x-intercept, is at 0, 0. So I'm just going to summarize all that information really quick. So the domain is from negative infinity to positive infinity. That's true for every absolute value function. And another way you could say that is all real numbers. The range of the parent function is from 0 to infinity. Now I'm using a square bracket because it actually touches 0. Use the round one because it never quite gets to infinity. The y-intercept is just at the origin, or 0, 0. You can say it either way, origin or 0, 0. And then the x-intercept of that parent function is also the origin. And over here on the side, you might actually write what the parent function is. Y equals the absolute value of x. So now, in part 2, we're supposed to describe the geometric transformation with respect to y equals the absolute value of x. Sketch the graph of each without a calculator. Okay. So let's look at A here. And hopefully you remember from about 5 or 6 weeks ago as well, that when you've got a minus 3 inside of parentheses, or in this case inside the absolute value, that means you go right 3. And that plus 2 means you go up 2. So if I were to graph this thing, I would go from the origin, and from the origin I'd go right 3, 1, 2, 3, and up 1, 2. And I'm just going to graph this absolute value function, except I'm going to start right here at this point. So you go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, and then you've got your absolute value function. Don't forget to draw some arrows at the end. Sorry. Draw your line straighter. Okay, so let's do another one. Let's do, let's do B here. So now we've got 3 things going on. We've still got that plus 1, which means left 1. And I got that minus 6, which means down 6. But I've also got this 2 here. And that 2 means that it's a vertical stretch. I'm just going to abbreviate that VS. Well, we're going to do the same thing as this problem right here. We're going to start at the origin, and we're going to go left 1, and then down 1, 2, 3, 4, 5, 6. It's not quite on there. I'm going to put the dot there. Now the question is, what's that 2 do? You might have noticed when I was graphing this guy, I went up 1 over 1, up 1 over 1, up 1 over 2, over 1. This 2 means we go up 2 over 1. So start from that point, up 2 over 1 in both directions. And then from that point I go up 2 over 1. From this point I go up 2 over 1. And now I can draw in my, hopefully, straight line with arrows. So that's a vertical stretch out front there. Well, what if it's not a number? What if it's just a negative sign? Well, hopefully you remember that's a reflection. That plus 5 means left 5. That plus 4 means up 4. So it's a reflection. We'll come to that in just a second here. you'll want to go left 1, 2, 3, 4, 5, and then down and down, or sorry, up 1, 2, 3, 4. So we don't have a lot of space here, but what that reflection means, instead of going up 1 over 1, up 1 over 1, we're going to go down 1 over 1, down 1 over 1. And I apologize, we don't have a lot of space on the graph here, but you can imagine that it goes down in both directions. So it's upside down. That's what that negative means. Let's talk about some of these in part 3 here. Given the following geometric transformations, find the equation, the axis of symmetry, the locator point, and draw the sketch. We're not going to talk about this locator point, but it's the vertex. So we'll just write the word vertex there. So we're talking about a vertical stretch of 3 in part A. So the first thing we're supposed to do is find the equation. Well, that's just y equals the absolute value of x, but a vertical stretch of 3 means I'm going to put a 3 out front there. So this thing's still at 0, 0, which is your vertex. So the vertex is still at 0, 0. And the axis of symmetry is just that line that cuts this thing up and down the middle there. That line is x equals 0. That vertical stretch of 3 now means we're going to go up 1, 2, 3, and over 1 in both directions. So you can kind of see how this absolute value function has been stretched out like that. Let's talk about part C, because we haven't done a vertical compression yet. What's a vertical compression going to look like? Okay, so y equals the absolute value of x. Now, vertical compression just means we put a 1/2 in the front here. And a vertical shift up of 3, that's just a plus 3 on the outside. Remember, the outside is up and down. The inside is left and right. Okay. So let's go ahead and write our vertex. So if it's plus 3, the vertex is going to be 1, 2, 3. Now, I'm not going left to right at all. So I know that this vertex is at 0, 3. And that axis of symmetry that's going to cut this v right in half, that's still the line x equals 0. All right, so I've got my vertex, and now I've got a vertical compression of 1/2, which means I go up 1 over 2 in both directions. Up 1 over 2 in both directions. So if I draw in this line, you can see that I've kind of taken the absolute value and pressed it down. I've compressed it in the vertical direction. Okay. Now the bread and butter of this unit is in part 4. This is really what we want you to be able to do, is in part 4 here. Look at a graph. Can you write the equation of the graph without a calculator? Okay, so we know it's an absolute value because it's got that v thing going on here. The vertex is still at 0, 0. So as I write the equation, y equals something, absolute value of x. I know that I don't need to shift it left or right, so there's nothing else inside the absolute value here other than the x. I'm not shifting it up and down either because it's at the origin, so I know there's nothing, no plus or minus on the outside here. What's going on is going to be going on in the front, in front of the absolute value. So you'll notice from one point to the next you go up 1 over 1, 2, up 1 over 1, 2. But that's a vertical compression of 1/2. So that's the equation here, just 1/2 absolute value of x. Let's look at part B here. We're still at 0, 0, so I'm not shifting it left or right, so I can go ahead and write y equals the absolute value of x. Nothing on the inside because I didn't go left or right. Nothing on the inside, or sorry, on the outside because I didn't go up or down. I'm still at the origin. But I went down 2 over 1. Down 2 over 1. So down means negative. It's upside down. That's a reflection. That's a negative. And since I went down 2 over 1, it's a vertical stretch of 2. So this is y equals negative 2 times the absolute value of x. Let's look at part C. Still got that V shape, still absolute value. But this time, from the origin, I went over 1, 2, 3. So I went right 3. And then I went up 1, 2. And it looks like this is up 1 over 1, up 1 over 1. So we don't have a vertical stretch or a vertical compression this time. What we have is the absolute value of x, and I went right 3. So remember, inside the absolute value, that's counterintuitive, so it's going to be x minus 3 to make it go right 3. And then make it go up 2, just write a plus 2. And it's not a reflection because it's going upwards. So there's no negative out front. This is the equation. Okay, last one, D. Looks like we got a little bit of everything in this one. So I'm going to give myself lots of space. Y equals x something something absolute value. There's 4 things going on here. The first thing that I immediately see is that this guy is upside down. I'm going to put a negative up there because that's a reflection. The next thing I notice is I have to go left 1, 2, 3 from the origin. Left 3. Then I have to go up 1, 2, 3, 4 from the origin. So left 3, up 4. To make it go left, that's a plus 3 inside here because it's counterintuitive. To make it go up, on the outside, it's plus 4. There's one more thing going on here. This is a vertical stretch because I have to go down 1, 2, 3 over 1 in both directions. 1, 2, 3 over 1 in both directions. So this is a vertical stretch. Question is by how much? Well, 3 over 1, which is just 3. So it's y equals negative 3 times the absolute value of x plus 3 plus 4. So this is really easy to do without a calculator, if you remember the bottom part here. So what's that a mean? What's that a going to tell you in the front of that equation there? Well, that's either a vertical stretch or a compression. And it's going to tell you how far from the vertex to the next point. It's basically the slope, more or less. This negative h, that's going to tell you how far to go left or right. So this is a horizontal shift. It's going to go left or right, and you want to remember that this one's counterintuitive, which means if it says plus 3, you're going left, and if it says minus 4, you're going right. And then, of course, that plus k is a vertical shift, meaning you're going down and up. So that's it. You're looking at graphs, you're describing the transformation, you're writing the equation, and in some cases you're given the transformation and you're graphing it. It's not too bad. This is more or less review of what we did 5 or 6 weeks ago. I hope this has been helpful, and thank you for watching.